Yeah, so each station is pretty specific to a certain line of products. Just because the tooling and parts necessary to do the service work is pretty specific to a product. But there's so many pieces that go into a fork, there's so many pieces that go into a shock, it's hard to keep them all at one station. Generally when people come to us, they're looking to get their stuff, quote, pushed. And pushed is our customization packages. So that's when someone has a certain expectation in mind. Whether it's a aggressive cross-country racer or a trail rider, what they're looking for out of their suspension is totally different. So when they come to us to get pushed, we work one-on-one with the rider to find out what it is specifically that they're looking for. Through the website or over the phone, we take an order so that when the suspension product comes in, we know whose it is, where it's going, and what we're doing to it, depending on what the customer's looking for. We have our rebuild services, which would include new O-rings and seals, fresh oil, complete teardown reassembly. We have what's called our tuning service. With the tuning service, it goes up a notch. We actually take this stock piston assembly that comes from Fox. It's a real good unit, but it's made for kind of a all-around, general use for bikes. We manufacture our own high-flow piston design. With the tuning, we'd offer our new what's called asymmetrical piston bolt. With the stock Fox bolt, it's a free-flow design. The oil can travel back and forth through compression rebound. With our bolt, it has a one-way valve, and what that does is it isolates the compression and rebound damping. So when we tune the shock and change the compression characteristic, it has no effect on rebound, and rebound has no effect on compression. So again, the piston design, this is just a sample of like a compression shim stack. These bins up here are loaded with thousands of different shims. So we have this set and this set over here. They're all different diameters and thicknesses, and that's how we tune the shock. So you have these kidney shapes, which are the compression holes, and the shim goes over and covers them up. So how you stack these shims, the diameter and the thickness, determines the spring rate and how they open up. And that's really the science of what we do. With the DHX, they have a few tunes that they can choose from, but yeah, you'll find that you'll have 5 bikes, all a little different and characteristic mechanically, but they'll all be spec'd with the same shock absorber. And it's not to the fault of Fox or the bike companies, it's just when the product managers are sitting down with Fox, they have to come up with what's going to be the best solution for a broad range of riders. And that's what we don't have to do. We get to work with the end user and find out what they're using it for. Because some guys use their downhill bike as a park bike, some guys will use it as a free-ride bike. Some guys use an all-mountain bike, for real aggressive terrain. Some people just like it as a lightweight, trail bike. The consumers buying today is, the mountain bikes today are great, and they all do a really good job of meeting that need of what are we going to have as the average rider, weight, style, etc. That's the other thing with bottoming characteristic. Again, the stock shocks just come with a single bumper. So if I pull the seal housing off, this is a standard bumper on a DHX. It's the same size and density for every bike. So this is a product where this doesn't change no matter what the shock valving is. And that's something where over the years we've learned that to control the bottoming characteristic a little bit better, we want to have different densities. So these are an example of 4 different densities, but we actually make 6 different densities of bump stop. So higher leverage bikes, again, get a heavier density. Lower leverage bikes get a lower density. So it kind of corresponds with the spring rates. So when you see bikes that have high spring rates, they get bigger bump stops. When you see bikes with lower spring rates, we get lower density bump stops. So like this is what's called our MX Tune package, where for some riders, we actually remove this whole bridge assembly. This uses the Pro pedal and the boost valve system. We'll actually replace this whole mechanism with a bridge that we machine. And so this will be replaced. And what this does is this is a motocross style adjuster. So you have a blue hex, which is your high-speed compression, and a silver flathead screwdriver, or screwdriver slot, which does the low-speed compression. This is something for people who like the fast and flowy, real plush suspension. It's just a fine-tuning mechanism. So again, we pre-build this reservoir assembly and pre-build the valving based on the rider form that we get, so that when they get it back, they can't really screw it up too much. It's not like they can find a real bad setting, whereas with a production shock that uses a high-low adjust.
So the neutral of the shock is built around the rider.
Exactly. Yeah. With this high-low adjust, it's what we call a bolt and go, where when you get it, the high speed, spring range, the low speed, the valving in the shock is already, like you said, neutral around the rider form and application. So when they get it, they can go out and ride immediately. Then they can start making adjustments and see if it makes it better or worse, but going one direction or the other direction isn't going to get them so far out of the scope that now the bike doesn't work well. A lot of times we will use factory parts, but you know, in some cases when we just feel like there's a compromise or something we want to do differently, we design, engineer, and make it here. The piston valving and the high-low speed valving, everything's preset, the bump stop. So this is a fully tuned shock ready to be bolted onto a bike. Doesn't have any stickers on it, so it still has to have the sticker applied. The decal, as they say in Canada.
I was told that you would set me straight on hysteresis, because I thought it was the memory that shocks had over like a trail, and they told me I was wrong.
Yeah, hysteresis, that's a really big one. Yeah, Jimmy was definitely involved in that. He probably, I mean, how many beers did you guys drink just trying to remember that word? Hysteresis, it's actually when a shock compresses and rebounds, there's a gap in the damping. So when a forker shock compresses and then extends, there's a moment in time that there's a lag in the damping, and that's what we call hysteresis. And our dyno in the other room, which I can show you a little bit later, actually is a tool that we use to measure that. So this is it going compressing. This is the rebound. Basically, what that other curve we just showed, but like kind of folded in half. Mm-hmm. And so this gap right here, that's the hysteresis gap. So that's that measurement. Smaller that lag time, the more responsive the suspension is. Oh man, I got my shock back from push, and the hysteresis is so much better. Awesome. Yeah, it's working good.
All right, thanks for coming to Push, guys. See you later. Have a good trip.